what I was saying is, for us to be able to set a working directory, we need to, the easier way is just for you to go to your file, to your folder where you have kept your data set, where you'll be working in, and then you go on, just click on the file path, then copy the file path, and then go to RStudio, and the code line number 11, just replace that with the file path, and then you can, if you're working in Windows, you need to put double slashes, backward slashes. You try to execute that. It gives me an error. Why? Let me see. Okay, this one is supposed to work. Okay, I forgot here. Yeah, so backward slashes, and that works. Or just forward slashes, just change the backward slashes to forward slashes, and then execute it by clicking on run or control enter. So make sure that your cursor is on that, you are on that line that you'd want to process or execute, and you get hit control enter or go on run. Or the other method is just select the code and then run, click on run, and you get an output. For you to check the file path, you just need to run line number 15. Okay, and it shows you in the console, it prints the path to your directory. So that is how you can set a working directory in R. I don't know if anyone is having difficulties setting a working directory. Okay, let's move on. So after setting a working directory, we would want to talk about variables in R. Like in any other programming language, you have variables, and an R variable allows you to store a value or an object. So a variable will allow you to store a value or an object, and variables which are containers for storing data values. So you can say, I want to assign 2 to x, and 2 is a variable. X will be your variable, and 2 will be your value. So like I demonstrated before, 2 plus 1, and hit enter, you get 3. If you type that in the console, you can say x should be should be equal to 2, and hit enter, and you'd say y should equal to 1, and hit enter. Then instead of writing 2 plus 1, you'd say x plus y. Okay, and hit enter, you get 3. Or you would say, I want multiplication, x times y, and you get a what are we getting? X minus y, you get a 1. Instead of each time to be writing so our 2, our 3 stored, our 2 is stored in x, and y is stored in y. Okay, you multiply 2 multiply by 1, you get a 2. So x is a variable, whereas 2 is a value. That's what we are doing here. So in R, you can use an equal operator to assign a value to a variable, or you can use the less than and minus symbol to assign a value to a variable. Or you can use the word assign, then x, comma, then you place a value. And assign x a value. What you mean here is I want my x to have a variable 10, a value 10 to be stored in a variable x. So if you run line number 25, the same thing for line number 27, you are doing the very same thing. Or instead of 10 here, you put 2, okay? And you still get the same thing. If you try to display, so to display a value, you just type the name of a variable, and then you'll be able to display in the console the value of the variable. Or you can use print if you're familiar with other programming languages. You would use print function to display a variable, a value of a variable, and then a value is displayed. So by just typing the name of a variable, you'll be able to run that, and then you get an output. Or by writing print, then the name of a variable, you'll be able to get a value. But in R, just typing a name of a variable is enough, and using print function, especially you can use it when you are working in loops. You are working with loops in R. We'll not talk about loops. You can use also an equal operator instead of the less than minus in when you are assigning a value to a variable, but it's recommended to use less than minus because the equal sign, there are some cases in R where it will not work. Okay, so let's move to the next part, is for us to look at data types. So there are multiple data types in R, and we'll look at a few of them. I'll look at numeric, Boolean, text. Numeric is a number, and anything a number is the type is numeric. So what I'm doing in line number 44, I am assigning a value to 12.5, a numeric value, to a variable known as, which I've called my numeric. It's also possible just to write number, okay, and assign it to 12.5. And for me to be able to see my number, so then I'll just type the same name, my number, okay, and I get down there 12.5 printed. One thing that I should mention is R is case sensitive, so my line number, my number with the uppercase M is different from my number which has lowercase m. So if I try to run this, it's going to give me an error. Error object number, not my number, not found, because this is using an uppercase M. So R is case sensitive. So this line number 47 is different from line number 44 or from line number 45. Okay, so the next thing is there is also logical operators, or there are also Boolean data type. A Boolean data type is to assign a variable my logical to true, and I run that, I get this is true. Or if I had assigned, if I had country, then I have an output USA. Okay, so there are a number of there are three data types that we've looked at: numeric, logical, and character. What I would want us to also mention, I would want to mention is what are known as functions. So functions is a set of statements that are organized together to perform a specific task. So in order for you to add two numbers, you want just to write a function, and when you put variables in that or parameters, the function should be able to add numbers or multiply numbers, or a function that would find a maximum number in a vector. So here is an example where we are saying that we create a vector known as x, and the vector should have three values, 1, 2, and 3. So we use a combine function to create a vector. Okay, so this function is the C function. You can place your values that you want to combine into a vector, like I've done here. So this is what I did here, and set x, and this vector should be stored in a variable x. Okay, execute that and then get an output, and you see that I have the values within that function. And then you want to find the maximum number in this function, in this vector, and you can use the max. So you use the max function. So this is a function that will find the maximum number in our vector x, and maximum number is 3. And if I want to find the minimum number in the vector x, and I get a value 1. So this is an example of a function. Another function would be a sequence function that would create a sequence of numbers specified within the specified range. So like line number 79 in my script here is creating numbers from 1 up to 30, and I can create numbers for a sequence of numbers from 1 up to 10, from 1 up to 20, etc. These are examples of functions, and these are built-in functions in R. You can also write your own functions, but that is beyond the scope of this session. Another thing that I want us to look at is R packages. Now that we've talked about functions, packages are a collection of functions that are compiled code or it's sample data. So you can have packages that are compiled code, functions, compiled code, or sample data. R packages, they are stored under directory code library in the R environment. To install a package, you use you write install.packages, then specify the package that you want to install. Line number 87 here, I'm installing a package SF, which is simple features. It's used to work with vector data in R, and this is what I had shared in my email that you are supposed to install. So install.packages, and then when you start writing something, you see that R brings a pop-up of, and you can select if that is what you are trying to write. Then specify SF and close that in double quotes, and then you hit run. So I want to install this because I've already installed, so just comment this out. But if you have not installed this, should be able to install it. So stread is just a function within a package SF. So a function is going to have a package is a collection of functions, and the function SF has multiple functions, and one of it, the package SF has multiple functions, and one of it is stread that is used to read data, so read spatial data in R. For you to load the functions, the packages that you have installed, you use library. So library function is used to load the packages. So I would say library SF. If I run this and my SF function is loaded. To get a list of installed functions, you can just type library without giving in a parameter. So library function without giving in inputting the parameters, and you run that, you get a list. Are packages available? So get a list of packages that you have installed. So that is all about packages, and finalize this discussion on R data structures before we transition to working with spatial data. So there are 4 data structures in R. We'll talk about vectors and data frame. So the vectors, matrix, you can have a list, structure, data, and a data frame. So there's an example that I'm just highlighting to say if you were analyzing weather data and you looked at amount of rainfall, magnitude of temperature recorded on a particular date, let's say Monday, 16th March 2024 up to Saturday, 21st March 2024, and you have observations recorded as presented here. Rainfall readings in millimeters. You have a day, you have the date, and the value of amount of rainfall recorded. And also for temperature, you have the same. You have a day, you have a date, and you have the amount, the magnitude in terms of degrees Celsius. For you to process this data in R, the first thing is for you to create a vector. You would create a vector for rainfall and a vector for temperature and a vector for date. So like an example is create a vector. I've assigned this vector to a variable rainfall, and then the values that I have in this vector, they are values of rainfall. And then if I want to find a maximum number, the day or the value, what is the maximum value, I would use the max function. And if I want to find the minimum value, I would use the mean function. So mean, and then brackets, and then inside there I put I type my variable, and I get minimum is 9 millimeters. For temperature, I would also create create a variable temperature, and then I'll say create combine the values into a vector. I can also find the minimum temperature, and it's 15. It's 13 degrees Celsius. Then I would create another vector day, and my values would be days. And you see that the days are in double quotes because these now are strings. Okay, so my days are created, and create another vector for date. And for date, I'm using as date function. And then inside I put a vector. So as date is used to convert these values into dates and not strings. Without the as date function, these would be strings. So I want my R to understand, or my computer to understand, that these are dates, they are not strings. That's why I'm using the as date function. Then inside there, I just put I put my dates as the values within this vector, etc. So that's what I'm doing. Line number 149 here. So if I execute this and check display, so these are different data structures, but what we are interested in is a data frame. So a data frame, in order to convert the vector into a data frame, you would use the data.frame. So data.frame is used to convert the vectors into a data frame or a table. So a data frame, you can just look at it as a table. And what you get is a table that has all the values that you had recorded. So temperature, so day, date, rainfall, and temperature. These are vectors that were created before, but now they are combined in a data frame. So using, so I say, okay, my table has to have a name, my weather as the name of a variable. The other things in the code which you can explore during your own time, but I would want now to transition to working with GIS data. I'm not sure if there are any questions up to this far. What I would do now is I'll share, let me share the code for this final session. So we can download that file, the R script, and open that in RStudio. Yeah, so yes, Ade John, you have a question?
Yeah, good day, everyone, and thank you for the wonderful session. I've been following suit, but I got disconnected by the network at a point. I would
No.
like to know how to make how programming read like our file. For example, excuse me, the
Yeah.
document is sent now, right?
Mhm.
If I want to call it on our programming, I say read dot. Is it a CSV file? Like I need to know if it's a CSV file so as to be able to run
Mhm.
it. hmm So I'll be able
Okay.
to run it.
Okay.
Yes,
Yeah.
sir.
So the file is an R script dot R. You see that there's a GIS in R, and then the name, okay, 23 March dot R. It shows that this is an R file, an R script, and it can only be read, or you can only work with it. You work with it in RStudio. So if you had downloaded R and RStudio and installed it as per the email that I had shared and using the sources that I had shared, links before, I think yesterday, you should be able to open this in RStudio. So what you're supposed to do is you need to open your RStudio, and when you open your RStudio, you go on File and then Open and navigate to where you have stored that file and open it in RStudio, and it's going to open.
Okay, thank you.
So like what I would do here is if I go to my R, okay, let me close it, and then I go on File, Open File, or Control plus O, open file, and I go into my folder where I've kept this script, and you see it's an R file. The type says it's an R file. Okay, and select it. So when you have RStudio already installed, you see that even the icon is going to show you that this is an R file, and select it and open, and it opens in my RStudio. Okay. So just as we did before, you're supposed to set your working directory. So all you can do is just, if you had already done that, you can just copy the working directories line here script code line, copy it and just replace line number 11 and with your working directory path. And I had shared with you this block of code from line number 16 to line number 21 in the email prior to this session. So what I wanted you to do is, if you had executed this block of code in RStudio, by now you'd have already installed these packages. So as I demonstrated, to install a package, you just write install dot packages, and then indicate the packages that you install. Now here we are installing 6 packages. The first is SF. This is a simple feature package. It's used to work with vector data in R. The next is Terra. This package is used to work with raster data in R. Then we're So we are installing tmap. Tmap is a package that is used for making maps. Then we're installing leaflet. Will not explore leaflet, will not explore ggplot2, but these are also used for visualization. So for to use leaflet, for you to create other, or for you to also create maps and other visualization products, graphs, etc. You can also use ggplot2. I'm not sure if we've all already installed our packages. Or we need some few minutes for us to be able to do that. Just a thumbs up if you have already installed the packages. SA2, have you already installed the packages? Emmanuel, are your packages installed?
Yes.
Great. Okay, still try. Okay. So what you just need to do is, so for me here, and for you, I just remove the comments. So the comments are, as I said, anything that is after the hashtag is a comment. So if I try to execute this with the comments at the beginning, this will not be executed. So if I try to execute this line, it's not going to be executed, nothing. But if you remove the comments, and the best is just do this, select line number 17 up to line number 22, like I've done, and click on run or control enter. It means you are you installing this at once. You need to be connected to internet. So I'm not executing them because I already installed this. But if you haven't, just highlight everything and click on run, or you can press control and enter. If you have already installed, you can move to line number 25 to 30, highlight those lines, control enter, or you click on run to load all the packages. So you need to load a package before you can use it. So I'll load all these packages because I already installed them. If you're having any issues, please feel free to speak out. Okay, so the first thing that we'll do is we'll read. Yes.
So it's giving me some error messages. For example, when I'm trying to
Yes.
install the package SF,
Yes.
it's not loading. It's not loading in.
What is it giving you in the console?
I think it's saying package or namespace load failed, as SF is load namespace blah 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 blah. I don't
Okay.
know. You said there's
Is
no
it
package called proxy.
is your can you check when you look on my screen here? You look at line number 17.
Yeah.
Is this line similar to the way this is your line?
Yeah. Yeah,
You've
it
taken
is.
you've taken away the first the hashtag that was there.
Oh,
You've deleted
okay,
it.
okay. I didn't take that hashtag away. Thank you.
Yeah. So when you have the hashtag at the beginning, do not process this line, and no, by default it tends to green, but you need to remove it and do the same thing for the other lines up to line number 22. And you can just select. So you see that after this line, after this I then this another hashtag, and then I got this vector data package. So the computer is going to process this part. For you to read data, just like you do in a desktop GIS, you use the stRead function. So the stRead function is an SF function, a function that is from the SF package. As we said, that SF package is used to manipulate vector data, and there are a number of functions because the package is a collection of functions that are performing specific tasks. Now, for you to be able to read data, just like in, so I'll just demonstrate here. If you are familiar with any desktop GIS, so I'm displaying here QGIS, and for you to load data in QGIS, you need to click on to go on layer, add layer, add vector layer is vector data, add raster is raster, and then you need to browse the way you've kept your data. So I'll try to do the very same thing, and it's my data. Okay, so approaches got a poor connection, internet connection today, and it keeps on connecting, disconnecting, etc. Okay, what error is it giving? Ramat warning, true is required. Um, Okay, so yeah, so those errors, yes, it gives you that error, those warnings, but it's okay. It is down there. It says package successful unpacked, so that's fine. It's downloaded. Binary packages are in. It gives you where the packages are been stored on your machine. That's okay. So if you see the warnings, you just disregard them. It doesn't mean that the package hasn't been installed. You can just try library SF, and you'll be able to see that you will load that package without issues. So that package has been installed, Ramat, despite the errors. All right. Okay, so to read data in R.
Sorry, sir.
Yes.
Okay, sir. You said that the error message still implied that my package has been installed, but I input the
Yes.
code, but it's not running any code.
Okay, so if you try to run line number 25, for instance, a library SF, and if you just try to run that, it should work uh, without issues, and
Okay.
it doesn't give any output, anything like what you would see in my console here, because all that you're doing is just to load that package, and it's going to print nothing. It's going to display nothing. So,
Okay.
but if it was not installed, if I try to run line number 25, it would give me an error that this package is not found. Okay. If I try, let's say, just anything that doesn't exist, library, so Dickson, and run that, it says error in library Dickson. There is no package called Dickson. But you see that if you had, if I run line number 25, it runs without giving me this error. So what it means is this package is loaded. It's installed. If it hasn't been installed, it's supposed to give you this similar error. It will have written error in library SF. There is no package called SF. That means that you have not installed it yet. Okay. And if you try to run line number 33, if you had not installed that function, SF, line number 33 will not work. It would give an error. But if it runs without issues, it means that package has been installed. So try to execute lines number 33 up to 37.
Okay, sir.
As I said, for you to be able to execute these lines without all of them together, you're supposed to select all of them and then run. Okay, so what it means is I'm executing all these lines at once. For me, I get all these lines run without errors. So it says reading layer Africa from data, and it tells me this is a simple feature collection with 50.
Okay. It says that package SF was built under R version 4.3. So I don't know, maybe is my R that is slow.
Okay. When you look at line number 11 on my screen, you see that I had set my directory to March 23, and within this folder March 23, there's a folder named data, and within that folder data, that's where I have the files that I want to read to my R. So what I'm supposed to do is when I'm reading the files, you specify the path. If you are not set a working directory, you are supposed to put in the entire path. Let me go. So this whole thing was supposed to be here. So let me just try to do this. So Africa here is my variable, and I'm saying that this variable should be assigned to the data set that I'm reading. So what I was supposed to do, then I was supposed to put the entire file path, if I not set my working directory to March 23, and then data, then the name of the file. So there is a file named Africa, and it's .shp, means that this is a shapefile, a vector data. So this is what I was supposed to do, line number 33, instead of if I had not specified my working directory to March 23. So here I'm only putting data, then africa.shp. Africa.shp is the name of the file that I'm reading to R, and this is a path to my folder within the working directory March 23. But if I not set the working directory to this, then I was supposed to place the entire file path. So this is a full path to my file, which is africa.shp. So you use the stRead function. So this function works for any other shapefile you want to read to R. So this is all that you need to know. For me to read a shapefile, I just need to use the stRead function. stRead. And you see, it gives you an explanation. Read simple features or layers from file or database. So read simple features file or database, or retrieve layer names and their geometry types, etc. So stRead function. What we specify in here is a path to the file and the file name itself. And then you assign this to a variable so that next time you want to use, when you want to use do anything to the file, you don't need to be specifying the file path always, and you'll be just writing is Africa instead of this entire file path. That's why you're assigning to a variable. How are we assigning it? We're assigning to a variable using the less than minus. The same thing would work if you just put an equal sign. Okay. And when you run these lines of code, you should be able to get successful to get these descriptions. It shows that you have successfully read these. So it's just like in desktop GIS, it means you have successfully added a file to your software. But in R, we are not seeing it yet. We are not seeing the geometries of the layers we have added, because we need to use the plot function. We need to plot them. I hope we are all doing fine.
No, I'm not. Oh, I'm not getting it. Like, I don't know. Is unable to read.
Okay, what message is it giving you?
It's telling me error in stRead. Could not find function stRead.
Could not find function
stRead.
stRead. That's your okay. Can we go back to can you try to run this line number 25 for me here? Something like this line of code, library, then SF. Execute this line by selecting it.
Okay, so
and then click on run.
when I selected library SF, right, it says error, package or namespace load failed for SF in load namespace. Then it says into brackets J, then an arrow I, then double bracket 1L, like that line. Then it says liblock libpath libpath version check equals VI, then like two brackets again, then J inside, Then now said there is no package called proxy. In addition, warning message: package SF was built under R version 4.43.
So I try. Can you try to run line number 25, library SF?
That's what I did just now. And
That's
it
what
said,
is giving that
yeah,
error.
yeah, exactly.
If you try to run line number 17,
17.
yes,
Install the packages SF, right?
yes.
Okay. So
What does it say?
is restarting R session, install packages SF.
Okay, so you wait for it. When it's done, then run line number 25, library SF, and then try the SSST read. It should work.
It's still saying the same error message. It's still giving the same error message.
Okay. When it's what?
Should I send a picture to the?
Yeah, you can send you can attach a picture in the chat. Then I'll take a look at it. Okay, so in the meantime, I'll proceed. After executing lines 33 up to 38, what we've done is we've added 1, 2, 3, 4, 5, 6 layers or 6 files to our R. So we've read the 6 files, and you can check the attributes of each of the files. So let's say by just typing, we said you can display the attributes, you can display the variable. Now the value here is the shape files themselves, and you can display by just typing the name of the variable. So I'll type Africa and then execute this, and in the console I see that there is this message: simple feature collection, 55 features and 13 fields. The geometry type is a multi-polygon, dimension XY, bounding box, geodetic, CRS, first 10 features. So this is what you look at here is a data frame, just like we talked about the data frame in the introduction, which is just a table, or in QGIS, desktop GIS, ArcMap, that is an attribute table. So like this table in a desktop GIS is similar to what is being displayed here. So what are here just displays the first 10 features. And you have admin, you have admin HGM0 underscore A3 POPAST, which is estimated population rank, population here, GDP, economy, income, continent, Africa, sub-region, region WB, the name in EN, which is English name. And then you have the values, specific names or specific digits, year or number of people, abbreviations for the countries, etc. And you could do that for all the other files, but we just try to see to check for the file Africa. To check the coordinates, you just type the name of the variable, and then $, and then you type geom. Geom is for geometry, because this is not just a table. This is it is a shape file, meaning that you look at both attribute and spatial component. It has both attribute and geometry. So geom is just geometry. If I run that, I am able to see the coordinates for the polygons. Okay, so these are the coordinates in red here. So the first five geometries. Of course, they are truncated here. I'm not seeing them in full. all the coordinates in full, but that's just to show you that this is not just a mere table. It's a table that has it's a file, that a data frame, that it's a geodata frame, that has location or spatial attributes. For you to check any of the column mean, and then run that, and you get the values of that particular column. So each column is composed of values that each column is an attribute. So there's an attribute called admin, and it's a name, administrative name of that geometry, which are the names of the countries of Africa, and these are the names that are printed here. So we need to prove that this is not just a table, but it has geometric features that we can plot. So this one is not in the code. It's after. Okay, I see that should come later. Now, if we want to select countries to find out which countries have a population greater than 20 million, we can use the DPLYR filter function, and that's why we had also to install the DPLYR function package, so that you can use one of the functions in there to use to select for selecting countries. For instance, selecting a specific value, or specifying a condition for a specific item of interest. In here, we're saying that you want to select a country that has a population greater than 20 million. So what we're doing here is we create a variable named population, and we are assigning this variable to the selection. And we're saying that we use the filter function, and within the filter function, we specify the file that we are selecting from, which is Africa. Africa is the name that we had assigned to this file. Okay, and this file has a column name, which is an attribute POP_EST, which is population estimate. And we're saying that population estimate should be greater than, and then we type 20 million. And if you checked your console previously, you saw that you had this column name, POPEST, which is an attribute, and there are values. So these are values. We're saying that any of the countries that have number of people greater than 20 million should be selected. And that's what we're specifying here. So this is the same thing. If you're familiar with desktop GIS, you would write an S. So the first thing that you do is for you to plot. Let's plot the original file so that we should be able to see the difference. Let's plot the original file. So what I want you to do, this was not there. It's not in the code here. What I want you to do is just type plot underscore, just as I'm doing, plot, and then open bracket and close bracket, then type in the Africa, which should be lowercase. And you see that when you had already assigned a variable at on the top there and executed it, And you would see now when you're typing, you would see that it shows you a pop-up. This is the data frame that we're looking at, the table that we're talking about. And you see the values here, admin, admin what, okay, all these values. And this is what we're printing in the console. And this geometry, that's what we're printing in the console. So type plot and inside there put Africa underscore for us to be able to plot this. And this is going to appear in the output here. So if you run that, get a warning message because you have a lot of attributes and you have number of things here plotted. So you have Africa, 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 and each of the attributes is plotted. This is for admin A, this is for admin A, this is POPS, this is pop blank, pop here, etc. So now we are convinced that we are looking at a spatial data set, not just a table. You can zoom the plot by clicking on zoom, and then it pops up in a new window, and then you look at this much better. I hope it's working. Can you close that window and go back? So you see that when you just use the plot function, it plots everything, but you may be not interested in plotting everything. You're just interested in plotting the boundaries. So for you to do that, you'd specify plot. So within Africa, we change this and put the dollar symbol and specify the attribute. So you see that you have all these attributes. We want geometry on a geometry, and type geometry and execute it. And now you can see a better map on the polygons, the boundaries of the countries of Africa are plotted. And if you are from Africa, you should be able to see your country. That is if you are familiar with geography, because there are no names yet here. So like for me, I'm from this country. This is where I am located. Okay, are we winning? Great. Okay, let me share the file. Yeah, so Adejon, the packages are.
Yeah, so I've been able to navigate.
Failed.
Hello, sir.
Yeah, hello.
I've been able to navigate loading those packages now. So I did not have proxy. Like my package was lagging proxy, so I had to like install proxy, then library proxy, then I loaded the other packages under it, then it ran. So now I've been able to also set directory to the file. Now I'm trying to run the line of code so as to meet up to where you are.
Okay.
Yeah, thank you.
All right, great. Okay, so now when you look at what I have, I can, as I say, that you can zoom the plot. You're just going on zoom, and then it opens in you plot. It opens in a bigger window, and you're able to see the file. Now we're convinced we're working with spatial data, and you can close this, go back to to the base RStudio. So the next thing that we do is, remember, we had only selected countries that have a population greater than 20 million. Can we also plot this to see that not everything should show like what we have here? We only want countries that meet this requirement. So you can use the same thing. We had created a variable population, and you can just say plot, then you specify the variable, which is population, and geometry. Only want the geometry to be plotted, not all the attributes. Plot geometry and run that, and you see now some of the countries have been erased out. Okay, they are not appearing on this map because they don't meet the condition. So countries that have population less than 20 million, they are not appearing. Only countries with population greater than 20 million are appearing on this map. Okay, so you do this same thing in QGIS, ArcMap, ArcGIS Pro, and then other GIS software that you may be familiar with or you have heard of. You do the very same things. Select features by attributes and then continue processing. We can, let's say, we want only to work with these for your task. Then that's okay. So if you change the condition to 40 and so not few countries, change to 80 million, and only 4 countries have number of people greater than 80 million. Yeah, so what if you are interested in a particular country? I want to only plot South Africa, for instance. See, we saw that we have people from South Africa. So what you just do is you need to specify the value of the attribute that you want to plot. Remember, when we were exploring this data before, we saw that there are some attributes or column names like admin. Admin has a value, and the values are the names of the countries. Also, there is name EN, which is English name, and there has values which are names of the countries. So what we'll do is we'll specify name should be equal to South Africa. So that's what we're doing here. Select South Africa. So we say I create a variable. I'm saying South Africa. So a variable is not supposed to have space. That's one of the rules. So that's why I'm putting underscore South Africa and assigning to the output of the selection using the same filter function. Filter Africa is the name of the file that I'm selecting from, and name en is the column title or the attribute, this one, and South Africa is the name, the value itself, and it's within quotes because it is a string. So if I just can we do this? South Africa. I'm assigning it to the output from this function. So the first thing is you have the function specify the condition, and I'm using double quotes. Yeah, so the presentation will be shared. I'm using double quotes because I will double equal sign. If I used only a single sign, equal sign, that would be an assignment, but an double equal sign is equal to. So this is equal to. So if I just type equal, that is assigning, assigned to, but double equal is equal to, and South Africa, and execute that. It runs without errors. For me to plot it, so I can just remove this other stuff. It's just a duplication. For me to plot that, and then I plot. So I type. So it's just like I type plot, then specify the variable name South Africa, and I don't want to plot everything. I just want to plot the geometry. Okay, and hit run. Yeah, now I have South Africa. Yeah. Okay, that works. So those are attribute queries, or selecting things by attributes. You can also select things by where they are located, like making spatial queries. So to make spatial queries, you would try to an example here. If we are interested in, okay, first select countries that are within the Eastern African region. Of course, this will also be an attribute query because there is already an attribute which is subregion, and you use the same filter function, East Africa, filter, sub-Africa, subregion, Eastern. So the first thing is, let's say we want to plot cities. Another file that you have is for cities, plot cities geometry. The same thing, just show the cities. So these are the cities of Africa, within Africa, which I believe they are major cities or capital cities. And then you would want to select cities that are within the Eastern African region. So first, let's see the Eastern African region. That's what we have in line number 74. So we create a variable East Africa, filter the data set, which is Africa, and subregion should be Eastern Africa. Okay, we execute that, and if we want to plot that, then plot East Africa geometry, just want geometry. So these are the countries in the Eastern African region. Of course, it depends with how data is demarcated. Sometimes Eastern Africa is, some of the countries plotted here are not considered in Eastern Africa. So like you have Zambia, Malawi, Mozambique, this should be Zimbabwe. These would fall in the Southern Africa, but in some cases you would see that all these countries would be in Eastern Africa. So these are the countries that are within the Eastern African region, and if we want to select now all cities that are within Eastern Africa, within East Africa, what you would use is what is an intersection. So ST intersection is a function that will select an intersection of two data sets. So the first will be the cities and East Africa. So an intersection of cities and East Africa is what is going to be selected. And everything that is outside that intersection is not going to be considered. So what it means, all the cities that are lying outside these countries, they're not going to be selected. Only just cities that are within here. How can you plot more than one country, not a region? So you want to plot, okay, let's see. Say you want to plot Malawi and the countries landlocking it. Okay, you need then to specify. You need to specify the countries. Okay, let's
Sorry,
see.
sir, we can't see your
If
screen
I
anymore.
remember. So like what we did, and also share my screen. How about now?
Yeah, we can see it.
Okay, great. So, okay, so you want to plot Somaliland, Ethiopia, and Eritrea. Okay, fine. We'll try to do that. Okay, so I'll try to do something. I did not try it. I've not tried it, but I'll see if it works. If it doesn't work here, then I'll see. We'll try to do it towards the end. Malawi. Does this work? It works in SQL. So this has an expected symbol. This one is not working. In order to plot, so in order to plot Malawi and its neighboring countries, you need to specify this. This should be all. So all, you just use this. I don't know what you call it. So you just use this. This is for all. So writing all is not working, but just using this symbol, it will work. So I'm specifying the name should be Malawi, or the name should be Zambia, or the name it should be Mozambique. It's written like that, or the name should be Tanzania. Tanzania. Let's see how it goes. And I plot Malawi and its neighbors. Yeah, so all those countries are plotted, but now every attribute has a specific geometry or a specific map. What I just need to do is specify that I just want geometry. I just want a geometry. Yeah, so I have Malawi and its neighbors. So this is Malawi, this is Tanzania, this is Zambia, and this is Mozambique. Okay, so let's proceed with our spatial query. Said we want Eastern Africa, and then I have Eastern Africa. I want now to select cities that are within Eastern Africa. What you need to do is one of the cities will be our X, East Africa will be our Y. So use East Africa, okay, use ST intersection, and this ST intersection takes an X and Y as an input. So you have X. So these are built-in things already. All you just need to know is that you just need to specify the X, you need to specify the Y, which are your data sets. So no need for you to go beyond anything like that. So just know if I can use intersection, just ST intersection, ST intersection. Today, if you are encountering this for the first time, it's like you are overwhelmed with a lot of information, but you see that the moment you do this again on your own, you see that you start to understand, and it sinks, and next time you won't have issues. You already know that all I need to do is use the rest intersection. That's all that you need to know. So that's what we're doing here. Okay, it gives me a warning. It doesn't matter. Then I would say I want to plot the Eastern African geometry. Okay, East African cities. That's what I will do here. So now you see, I'm doing this. I have cities that are within East Africa and a plot. So these are capital cities plotted, and I've assigned them color blue. So one thing I've done, I've added more things to plot. Instead of just plotting the geometry, you see, I said plot cities, then geometry. I'm plotting cities, add equals true. Why am I putting add equals true? What I'm doing here, I'm saying when I'm plotting the cities, this should be added to the previous plot, which is the East Africa itself, the geometry, so that I'm able to see these things together. That's why okay, that's why we are having a plot. We are having add equals true, and color, this core equals blue. I'm saying that this should not have black color, the default one. The color should be blue, and I can specify the size. Okay, so there are a lot of things that you can modify. There are a lot of ways of modifying your plot. These are just a few of these. Okay, so yeah, so if some country is not shown on the map or in the data set, it's just maybe because of the data set that I got this from online. You know, maybe some of the changes some of the changes are not in there, but yeah, so they say Somaliland is there, so Somaliland is here. Okay, and if it's not here, if there's any country not here, it's just because of the source of the data set. So I downloaded this data set from Natural Earth. Okay, so that's okay. We are happy. We can plot all the cities to compare. So if I run line number 89, so other cities that are outside this are also plotted, and you see that's what you got. You get there. I can zoom in and see that Africa extends this side, and the countries that are not of interest, cities of not interest, are these ones with that are not in blue color. That's okay. One thing that you'd also do distance operations in QGIS. I keep on referring to QGIS because it's one of the desktop, a powerful, free and open source desktop. You can also do distance operations, like you create a buffer. Imagine you wanted to find, you are working with maybe an environmental affairs department and you are implementing conservation efforts for a particular river, and you would want to create a buffer zone where you want to demarcate to say that nobody should cultivate or construct within 10 kilometers, 10 kilometers too big, maybe within 100 meters of a river, of a particular river, for instance, and you'd specify that all your that you do in GIS is create a buffer, find a shape file for a river, and then create a buffer and specify 100 meters, and then you'll be able to find anything that is within that, whether it's buildings or farmlands, etc. So that's what we do. That's how we would address that question using GIS. So here we have just an example where we're saying that you want maybe to create a buffer of 30 kilometers for each of the cities. So before you create a buffer, before you perform distance operations, what you do in GIS is there is an issue, there is a subject on map projection. So a map projection is a presentation of a three-dimensional Earth on a flat surface. We are looking at Africa here. When you look at the plot itself, you'll see that it's on a flat screen. But the Earth is not as flat as we are looking at it here. All that has been done is to project the three-dimensional Earth on a flat. So instead of looking at the Earth in form of angles, as degrees or decimal degrees, you look at it in form of distance, like in terms of distance units, meters, kilometers, or miles, etc. So that's what you do first before you run distance operations. But do not do that. We can run lines, like for me, it's line number 93 up to line number 108 during our own time. But we proceed to line number section on cartography, which is line number 110 for me here, because we're running against time. Now, after you've done every analysis ends up with creating an information product. Whether an analysis is going to take 2 days, a week, a month, but we want to present that in form of a product, something that a user can look at. So how do we create maps in R? So we have already looked at one of the ways using the base function, plot function. But plot function is limited. So there is a specific package that was developed for us to be able to work with maps in R, and that is the tmap package. So that's why we're installing the tmap package, and that's why we had loaded it initially. So this is the basic building block of a tmap package is tm shape function. It's the basic building block. It defines the input data. So in tmap shape function, tm shape function, you specify the data input. It can be vector or raster. So what it means is when you want to plot anything using tmap, you first need to start with tm shape. So this tm underscore shape, just like the way we are saying plot, and then open brackets and close bracket. So the basic building block is tm underscore shape. And that's all you need to first know. Anything is added to this one. So in this, just like in plot, we're specifying when we wanted to plot for Africa, we're saying plot, then we're writing Africa. So in the tmap function, the same way, you write TM shape and specify the data set. I want to plot Africa. Okay. Then you can specify for your polygons. Okay. So if I run this, nothing to show. So it says, it tells me nothing to show. It runs successfully. There are no data layers defined after TM shape. After TM shape, I'm supposed to define how this should be plotted. I just want polygons. I want borders of the countries, or I want the colors. The geometry, the polygon should have a specific color. So use a plus. A plus is to add other functions. So one of it is TM fill. TM fill. What I'm telling R is I want this map or the plot. The polygons should have a fill color, should have a specific color. So by default, if I run this, they are going to have a gray color. So you have all the countries grayed out, and the boundary is also grayed out, and you just have Africa in gray. If I want to have borders, and then I need to add, just use as a plus. Plus is add more stuff. I want to have borders. So then that's what you have that plot. Now I have fill color, but I also have borders. But TM fill, TM borders, all these can be done by TM polygons. So if I run TM shape Africa plus TM polygons, it does all the work for me. You don't see changes. Or let's do this. You can go here. There is this remove current plot, or you can clear all the plots. So if you click on that brush icon, clear all the plots, so this can be empty. So that you see that this, if you run again line 125 for me here, I run that, I see that it really does all that TM fill and TM borders were doing to Africa, to the shape of Africa. The next thing would be, maybe I want to add more things. So we're saying I want to add a border layer to the shape of Africa. And that's what we're doing between the code block from 128 to 135. More things added. What I have the shape of Africa here. I've also added the roads, and I've colored them red, and the line width should be 1. I've also added cities, and the color is black, size 0.5. Now you see I have a map that has both the countries, serve as the country boundaries, and also there are roads plotted on the same map, and points which are cities plotted on the same map. What it means is TM shape Africa, and with the specifics here, I then TM shape, then specify roads, and then TM lines. Now it's not TM fill, but it's TM lines because roads are lines. Specify the color and the line width, plus this should be added to the same plot, TM shape cities, and then plus these now cities will be TM symbols, and lines TM lines, and geometry, I mean polygons, TM fill, then TM borders, or TM polygons, because these are polygons, country boundaries. So that's what I've done here, and you get that output. Country boundaries and the roads within Africa and the cities. Okay. Now we need to, so we're saying that we want to add a fill and a border layers to Africa. So another code 137 up to 144, you can run that and see what you get. Okay, it's the same thing, nothing new. What if I want to plot the population for Africa? So the population for Africa, remember that we one of the things that we had in the shapefile for Africa is population estimate, and you can plot this on a map in the form of a choropleth map, what is known as a choropleth map. So some people would use just a basic for and run that, and you have population for Africa plotted on a map, and where you have the dark colors, that is showing the countries that have a lot of people living in that area, and lighter colors, lower population. But this is not the best way of plotting population, because in this case we are plotting what are known as totals. This is total population, number of people, and you don't plot number of people or totals for polygons. Of course, there are people do that. You find that such maps appear in reports or publications, but it's wrong in terms of cartography, because you may have a lot of people living in an area just because the area is big, and not. So when you compare that to a country, let's say South Africa, compare South Africa to Malawi. South Africa has a bigger area in terms of size of the country, and it will have a lot of people because the size is big. But Malawi, the size is small. But if you want to make proper comparison in terms of number of people, you're supposed to plot population density if you are using colors. So like, for instance, of Rwanda, Burundi, whose country area are very small, but in terms of population density, you discover that the number of people per square kilometer, population density, is high. So you use population density. That's why we had one of the files which has population density calculated, which we had read, which is Africa project. So Africa project is the name of a file, an attribute that was assigned to a file that has population density for Africa, and that's what we're doing. And line number 155 here. Yeah, so when you look at my product, it has the colors, and then the legend, and this now is a proper map. Looks nice. Okay. Few things that I have to specify here, to highlight. So the basic building block is the same, TM shape, and then the name of the data set that you are plotting. Then we use TM polygons, but then a lot of things have been done here, specifying the fill color. I'm saying that the fill should be population density. POP then stands for an attribute within the table itself, which is name is population density, and I'm calling that attribute, and I'm saying fill equals POP then. What I'm saying is the color should be based on color the polygons based on population density. Fill.scale, I'm saying that the values should be greens and blue, meaning that so I'm saying that scale, the values should also the scale of the values, the fill colors should be greens and blues, and these colors, they will be indicating whether you have deep colors. Deep blue, for instance, is high population. Deep green, higher population, and then lighter colors, low population density. Then I'm saying I want also to have a legend, or what is also known as a key. And that's what I'm saying, that then I say comma, then I say field.legend, then TM legend should be, a legend should have a title. Then I'm saying title equals persons per SQ kilometer, which is persons per square kilometer. And where should this legend be? This legend should be positioned at the left bottom. That's why I have a legend left bottom. If I comment out this, okay, if I take out this stuff, let me take out this. Yeah. If I remove this and plot, now you see that my legend is outside. No, that's so my map will not look better that way. That's why I had to specify the position of my legend. So for now, it will look like it's too much. Like, how do I remember this? You just need to know it, and when you know it once, then it means next time you make a map, all that you'll be doing is changing the same code. You want to position a legend somewhere else, maybe you just say right top. So that's all that you'll be doing, nothing else. Why am I pressing it left bottom? Because when I plot this map based on the shape of Africa, you see that on my page here, where I have a lot of empty space is top, left, and the bottom. I will not place it here. I cannot place it here, but there's a lot of more empty space here. That's why I'm left bottom. So depending on the shape of the geometry that you are mapping, you'll see, you will determine where to place best the legend. Okay. So you can run other parts of the code, just few things that are changing, but similar stuff. We are changing in line, let's say 169, 165 to 169 is just changing the way the map legend, the legend is the boundaries of the legend. So on line number 165, we can assign even the entire map plot to a particular attribute, to a particular variable. Let's say I've created a variable Africa pop density, and this code is the same similar one before, but what I've just changed is the break. So I've introduced breaks here. Here we are saying that the way these values should be, the range of these values should follow this order. Okay, you may have a particular interest, and then you can do that. Okay, and that's what we've done. And you were saying that TM shape, what you get there, and you should have also the title, you should have a scale bar, and you should have the graticules. And if I try to plot that, I have now a map of Africa with title, legend, and the graticules, with a scale here. So see, this is a nice map that can go into a report or a publication, you know, but it's just been made in R. So if I want to save this, you can use this button, export, save export. So you click on export, save it as an image. Okay. And it's saved like that. Or you can use the tmap function, tmap save function. So you say tmap save. Oh, sorry, save, and specify what are you saving. I'm saving this plot, and what should be the name. Specify the name, population of African countries, and what should be the type should be an image.png, should be a PNG image. Then I specify the .png. So if I run execute this, my map is saved in my working directory as an image PNG, and the name is population of African countries. To verify, I can go to my working directory, and I have it here, 9:40 p.m. If I open it now, that's my map. Okay, so this is where I will stop at. There is still a lot down there, but it's similar things that you can just try to execute and see what you're going to get. Okay. Okay, it gives you here somewhere, but I can just comment out this guy and comment out this guy. So what you have down there is adding more things to make a lot of things that that you would use to customize your plot, etc. But just to show you that there's more that you can do with R. So like this is a map that has been made purely in R. Let me know if there's anything before we conclude. Otherwise, we've gone through a lot. I know it's too much for the if you are working for the first time. But what I would encourage is to just go through this again on your own, and you see that you get to understand how things go, and then there's things that you just.
Hello? Hello, can you hear me?
Okay, so someone is asking about the grids. So how do you add the grids? The grids were added this way. There is TM graticules. So TM graticules is a function, a tmap package function that is used to add grids to the map. TM scale bar is a function that is used to add a scale bar. TM title is a function that is used to add a title. So you just specify the title of the map. And that's what you do. TM, the legend is used to add field legend. TM legend is used to add a legend and a title, etc. So those are things that you just need to know. And once you know these things, it's not something that you would labor again to create a map if you don't want to go to be using. So well, in R you can do a lot of stuff, but the issues like digitizing, you cannot do them in R. Then you do that maybe in desktop GIS. But this just shows you that R has more abilities than just regression analysis and other statistics that you may have been using R for. So you can change whatsoever. There is my name in the code. Put your name, put the date, specific date, and etc., and post the map. Sharing the code. So the code, I've already shared the code. This code is already there, and so the code that I shared has everything.
Yeah, sorry. I want to get the image for the last Hello? Can you hear me? Hello?
So
Hello?
yes, hello, I can hear you.
Okay, I want to try and get the code for the last but yeah, exactly this point. But I'm unable to like get
Yes.
this image, this Africa capital city image after running the line of code. I don't know why.
Gives you an error.
Yeah, it's saying error data
Yeah.
/r.png is neither a valid path or URL. That's immediately
Oh,
after running that
okay.
line
So
of
what you
code.
should do? Yeah. So what you should do is, what I was saying is, you can edit this code here, cartographer. You can put your name and you can put the date of today, which is 23. So that the map here should not show my details and should have the name and the date. And why that error is because of this portion. So there's one file that I used on this map. So that this is made in R, and I don't have that logo in the folder which I shared with you guys. So that's why you are not able to get that. But so because of that, all that you just need to do is so it's this file which is as R. So for me, if I would place this in today's data folder and copy it there, if I try to run this code, it will work. Let me move the comment because now I have that file. So if I do this and do this, no, this. So now I have this plotted on the corner, this R, so that you can post it on my social media platform, then with a logo of R, not showing that this has been made in R. So you don't have this file, r.png. So all you can do is just remove what I'm highlighting here. You can just delete that part and then run this code and run this the following Africa topo, and you see that it's going to plot and you have the maps similar to this one. Otherwise, guys, thank you so much for attending and for your interest. I've introduced a lot of things, but you can build on this and do more. There's more that you can do in R, but these are the basics and it's the building blocks for everything that you'll be doing in R when it comes to working with GIS data. You can also work with remote sensing data. You can work with raster data files, create digital elevation maps, etc. I will share the recordings later, and I'll let you through your emails. And I hope that should I come up with something else, then you'll be able to see it through my media platform, especially on LinkedIn, another session that I would come up with later. But for now, this is the final session for the month of March, and I hope you found the session useful, and there's more that I will be able to share as we go along. Thank you so much, and have a great afternoon, a great evening, or a great morning, depending on where you are connecting from.
Thank you.
Thank you. Bye-bye.
Thank you.